Okay, so let's look at some basic terminology. How many of you have heard the word spectrum? What is spectrum?
It's a frequency band.
Okay, band of wavelength. Okay, okay, some people are typing some answers. Okay, so think of consider some what should I say, consider a wired communication. Okay, let's say let me turn on my camera. Let's say you have a phone, okay, and you want to connect it to the laptop. Okay, so what you do is you take your USB cable and you connect it to your laptop. Let's say on one side of the cable is your phone, other side you are connecting it to the laptop. So that's how you connect it, let's say using a USB cable. Now let's say you are connecting it to internet. You want to connect your laptop to internet. So what you do is you take a LAN cable, for example, in a wired case, and you connect it to internet, right? So that's what you do. Now when you do this, the purpose is you want to do some data transfer. Let's say you want to transfer some information from one place to another. So you are using this wired communication. So you don't have to take anyone's permission, right? So if you want to take, let's say you want to connect a USB cable between your phone and your laptop, right? You don't have to take anyone's permission. You just have to connect and you have to do your data transfer. So nobody is going to question you, and unless you're doing some illegal activity, right? It's not a big issue, right? Now let us consider a similar case for a wireless communication system. Okay, let's say you want to transfer something over the air. You want to transfer something from your mobile without a wire, without USB cable, without LAN connection. Then what happens? Then if you do that communication, you may not only land in trouble, like you may be fined or jailed, and it may also it could also be fatal, because you're transmitting something over the air. And to transmit something over the air, you need a license. Okay, so that's the difference. So what exactly the difference between wired and wireless communication is? Wired communication, mostly when you don't have to really worry. You're connecting two devices and you're transferring the information. But let's say you are doing a wireless communication, right? Forget about what information you're transferring. The very process of transmitting something over the air itself can be problematic unless you have a license to do that. Okay, so that is a big challenge. Okay, so when you're designing a wireless system, you need to keep in mind, am I even allowed to transmit over the air? Okay, so that's why when you buy any electronic device, if it has a wireless transmission capability, you will see that it would have some kind of a license on the back. So it would have some, India, we have something called as WPC. So you would have seen some other licensing from some other country. It could be FCC in US. So there are these, organizations which say that, okay, you can design and you can transmit information over the air. Okay, so that is what is the difference between wired and wireless transmission. Okay, I hope this part is clear. So now you may ask, okay, what is all this to do with spectrum, right? We are talking about spectrum here. So this is the definition of spectrum. Okay, let me close the chat window. Okay, spectrum can be defined as all useful frequencies available in a region for various purposes like defense, safety, space, entertainment, communication. So someone already said that, data is the new oil, right? Somebody already typed saying that data is the new oil. So think of spectrum also as a natural resource. Okay, think of spectrum as a natural resource. And who controls natural resources? Who controls natural resources? Think of natural resources like water or oil or gold that we have. So who controls all these natural resources?
Governments.
Exactly, right? Government controls this. So in a similar fashion, spectrum is a natural resource, right? It's the available range of frequencies that can be used for all these purposes. So it can be used for defense, safety, space, entertainment, communication. It can be used for all of these purposes, and hence it is controlled by government. So if you remember, some of you who were in early 2000s, you might have heard of the infamous 2G scam, right? 2G scam was basically spectrum allocated for 2G technology. So there was a scam in allocating the frequency bands because it's a natural resource, right? obviously if somebody is going to bribe and say that, okay, I'm going to pay more, so give me more spectrum, right? So then that's how, then that's not a good way to, allocate the spectrum, and that's how that scam happened, right? So you may have heard about that 2G scam, because it's a natural resource, and all these operators want more of that spectrum. That way they can provide their services. Okay. Now, when we talk about spectrum, right? So if you're from electronics background, you would have heard, heard about frequencies. So if you see this particular picture, what I'm showing here is, you can see a spectrum chart here. So this is a very small picture. So it starts all the way from 3 kilohertz up to 300 gigahertz. Okay. This is from a US spectrum chart. So what I will do is, I will show you a bigger version of this picture image. Is the screen visible?
Yes, sir.
Okay. So you can also download this. This is available on internet. So if you look at closely, right? So this is, you see in US what they have done, they are saying that, okay, these are the frequencies. It starts all the way from 3 kilohertz. And if you zoom in, right, they have also given what is it used for, right? So you can see radio navigation, some maritime mobile, some fixed line communication, right? Radio navigation, aeronautical radio navigation. So you can keep moving like this, right? You keep moving from left to right, and then you scroll down, right? Then again you move from left to right. You can see that what these all frequencies are used for. Okay. Now if you scroll up like this, right, you can also see that when you go to let's say somewhere here on the right side, you can also see that there is something called as mobile communication here, right? Mobile communication, there's mobile communication, right? So you can see that it is very crowded, right? If you look at this chart, it is very crowded. That means there is only certain amount of spectrum available, and it is allocated for numerous applications. So obviously when you are designing a wireless equipment, right, be it a mobile phone or any 5G device, it has to fit into some of these spaces, and that space is decided by the government. So they say that, okay, you get a particular space, this particular frequency spectrum, where your device should work. If you work in another color, right, if this is the allocated space and if you work in a different region, then that's a violation. Okay, that's not legal operation. Okay, so if that's how if you keep scrolling down, you can see that all the way it goes up to 300 gigahertz. Okay, and I'm showing you this chart because in India also it is very similar. Okay, I could not find any chart. I've been searching for many years. I could not find really a chart which is so descriptive like US chart for India. Okay, but you can imagine that we will also have a similar chart where the government would have said that these frequencies are used for this particular purpose. Go to the next topic. So when we talk about spectrum, so this is a sine wave. I'm sure all of you know that this is a sine wave. So why am I showing a sine wave? Is because when we talk about spectrum, we also call it as microwave communication, or we call it as RF communication. RF means radio frequency communication. So whenever we are talking about frequency, obviously there is a relationship between frequency and wavelength. So if you look at a simple sine wave, so one wavelength, right? One wave represents one wavelength. So that is what is shown in this picture. So when we talk about 5G technology or even 4G, RF or microwaves, that is what is used for radio communication. So what happened is in the earlier days, communication was done in very low frequency or very high frequency or ultra high frequencies. As the technology progressed, right? As the technology progressed, government started allocating higher frequencies. So higher frequencies, what I mean by higher frequencies is, let's say these, this is the lowest frequency and this is the highest frequency. So earlier the communication used to happen at lower frequencies. Slowly as the technology progressed, when we moved from 3G to 4G to 5G, government started allocating higher frequencies. Okay, somewhere here, let's say somewhere here, government started saying that, okay, you can use higher frequencies because it has its own advantage. So these waves are called as microwaves or RF waves. So if you look at this image, right? So I have just zoomed in this image. So if you look at this portion of the US spectrum part, this is the image where it is saying that this is the radio spectrum. That means these are the frequencies that are used for 5G technology. So if you see here, something is written as microwaves. Can you see this part here? So it is written as microwaves. So you can imagine that this is the space where all your 4G, 5G technology works, even Wi-Fi for that matter. Okay, so this is the spectrum that we are interested in. Okay, so if you remember, frequency is always expressed in megahertz and gigahertz, and wavelength, it has an inverse relationship. So it is expressed in centimeter and millimeter. Okay, so if you see this chart on the bottom, everything is in frequency. Okay, it shows from 10 kilohertz all the way up to 100 gigahertz, and on the top it is all in wavelengths. So it is expressed in meters, centimeters, right? So that is what this chart represents. So when we talk about communication in 4G or 5G, so we talk either in frequency or in wavelengths. Okay, so the key takeaway from this slide is there is whole lot of spectrum. Okay, all this chart, this entire chart that you see, this is the entire spectrum that is available as a natural resource for any country. Okay, and what exactly we can use, okay, for a particular purpose, that is well defined by the governments. So that should be the key takeaway. The entire spectrum is not available for any particular application. It is defined based on the availability. Okay, somebody is saying radio communication highest frequency is 100 gigahertz or 300 gigahertz. So right now the highest communication frequency is allocated for 5G is up to 100 gigahertz. We don't have at least communication at 300 gigahertz. Okay, it has its own disadvantage. As you go higher in frequency, the range of communication is very small. Okay, so when we talk about range, right? So the distance that you can communicate is very small as you go with higher frequencies. Okay, so the smaller frequencies are better if you want to send the information to over a larger distance. So I'm the founder of company DTRI. So it's an upskills company where we do embedded systems, IoT, and 5G technology certification programs, and we also do placement for engineering students. So you can contact us. So there is a website that you can visit, ttri.in. You can also connect through, you can send me an email, or you can also send WhatsApp message on this number if you have any questions. So please join our LinkedIn group. So you can type Deshila Technology Research Institute on LinkedIn, and you can join our page there. And you can also ask questions there, and also about any new events that we are conducting. So we frequently update this page with our events. And just to give you a quick glimpse of what we are doing in terms of research. So so we are based out of Mysore in Karnataka, and we have our own 5G test bed. So this is the picture of 5G test bed, which is used for education purpose. So if you see here, I've written the use cases. So we use it for EMBB focused configuration, some kind of testing and all that, mainly used for education and research. And we have collaborated with the Institute of Science, Bangalore. Department of Science and Technology has funded this program, and we are based at SJC Step Mysore.